Hi there, what are the acids? What do they do? What's this business of neutralisation? Find out. Roll the graphic. Hi, I'm Paul, this is Science That Sticks, and in this session I'm going to talk about acids and neutralisation. First of all, what is an acid? Well, there are three main acids that you need to know about. You need to know about nitric acid, hydrochloric acid and sulfuric acid. Let's throw these bad boys up on the wall here. Not literally, let's just look at their chemical structures. So these are the three acids that you need to know about as GCSE students. HNO3, nitric acid, and it's dissolved in water, AQ. Hydrochloric acid, HCl, dissolved in water, AQ. Sulfuric acid, H2SO4, dissolved in water, AQ. Now, what makes these acids is the fact that when they are dissolved in water, they will dissociate a H plus ion. In the case of sulfuric acid, they dissociate two of those. Let's check this out. Now then, this particular type of demonstration with how acids work is really limited for higher tier students, combined or triple, but I think it's worth everybody having a look and learn about just how they work. So the H part gets dissociated. Essentially that means it sort of moves away from the NO3 ion. And because they're all dissolved in water, you can imagine that these H plus ions are floating around in the water, dissolved in the water itself. It's probably the best way a GCSE student can think about this. The same is true for hydrochloric acid and the same is true for sulfuric acid. The amount of these ions that are dissolved in the water is directly linked to the pH of the water. Now, if you're going to do A-level chemistry, you learn more about pH and you learn more about concentration of hydrogen ions, and we don't care about that at GCSE, not just yet anyway. In fact, actually we don't care. Now let's look at neutralisation. Now, one of the things you need to know about is neutralisation. Now, neutralisation is the movement of the pH value from a low value, so 1 or 2, up to 7. And 7 is the pH value of a neutral substance. Water is a neutral substance, but things can be dissolved in water and it still have a pH of 7. There are a few ways that you can do this, but in every single case, to make a neutralisation reaction, you must have water produced as a product. So you always start off with the acid. If we add an alkali to it, like a metal hydroxide, we end up with a salt and we end up with water. An example of this would be sulfuric acid with magnesium hydroxide to create magnesium sulfate and water. Pretty easy. We can also use a base. Now, base is not soluble, but if we look at the bases, we get a metal salt and we get water. Now, an example of this would be magnesium oxide reacting with sulfuric acid to make magnesium sulfate and water. What other examples can I think of? Well, we've got an acid reacting with a metal carbonate. That'll do the job too. Now, if we've got a metal carbonate, like magnesium carbonate, and we react it with sulfuric acid, we will get magnesium sulfate once again. We get carbon dioxide, and we get water. In each of these cases, water is a byproduct, and because of the presence of the water, we can say it is a neutralization reaction. All of the acid has been neutralized. A pH change of the acid would occur if you have an acid and you react it with the metal, because the number of H plus ions in the solution would actually decrease, and therefore the pH would increase. However, water's not produced. Instead, you get the metal salt, and you get hydrogen gas. And that hydrogen gas obviously is not water, it's just a gas. The pH would change if you were to measure it, but it would look kind of a mess, and it's not considered really a neutralization reaction. So that's the three main acids, roughly how they work and how we can neutralize them, and a touch there on pH. If you go beyond pH of 7, you get into the alkalis, okay, and that is a different kettle of fish altogether, and we don't cover that in much detail at GCSE. So that's it. Until next time, ladies and gentlemen, as always, stay cool. See you soon. Bye bye.